Well, thanks everyone for tuning in to today's webinar, possibly the first of a two-parter. That's a little bit of foreshadowing about managing changing data. If we go back 2,500 years, our friend Heraclitus said the only constant is change. And I think living through 2020, none of us would disagree with him. Heraclitus also, incidentally, was into the flow of things, and I guess he would say, let the data flow and go with the flow. So he was really a man well ahead of his time. But anyway, there's change everywhere in our world and our data as well. And so we thought we would do a webinar showing how we can apply some different techniques to managing changing data. I think I missed a slide of introductions, but in any case, why don't we stop there and let's introduce ourselves. My name is Dale Lutz. I'm one of the co-founders of Safe Software and been at it for almost getting close to 27 years. So boy, oh boy, it's getting to be a long time. But I'm joined today by...
I'll go first. I'm Nampreet Singh. I'm part of the Desktop Technology Experts team, helping our users succeed with FME, and I've been here just over 2 years now.
Okay, awesome. And plus you were, I think, an FME user before that, right?
A light FME user.
I remember you took training from us long ago.
I did, yes, I did.
Awesome. And then we got to go all the way, far, far away to talk to Trent.
My name is Trent Kading. I also go by the Trentster. I'm a distant relative of the Zipster, actually, twice removed. I'm on the technical experts team, and yeah, looking forward to showing some demos.
Awesome. So yeah, so glad to be joined by Trent and Nampreet today that we'll dig in a little bit more into some of the applications of the technology and some of the use cases, and we hope that it's going to inspire you to perhaps have new techniques and ways of working with data that's changing and maybe help you find insights and basically get more value out of the data you've got. So yeah, today we're going to take a look at some of the theory behind changing data, a little bit about how we got into the biz, as we say, of change data detection and reporting, going way, way, way back to our roots. We'll do a variety of live demos involving a variety of formats, because that's kind of what we love doing. And so you're going to learn about IMDF and actually we're even going to go all the way, we're going to go all the way from CSV to ArcGIS Online. I think it's basically going to be a dizzying format tour of change. Actually, who else listened to David Bowie this morning to prep? I did listen to Changes this morning, and that was how I got ready. Between Heraclitus and David Bowie, we're all set from a philosophical point of view. So yeah, the idea that we want to get across, and we hope you'll leave the webinar with, is that it doesn't matter what kind of data you have to begin with or where it is in your workflow. If you need to detect changes and work with them, it should not cause you consternation. It should be just a relatively easy thing to do. And actually, I'll make the point, Mark Stokes, who's joining us on Q&A, I think is Dan Eisminger. I don't know who else is on Q&A, but we got a couple on Q&A today. But Mark in the prep pointed out that when he looked at some of the demos you're going to see, there was way more kind of at the beginning and at the end than it was actually detecting changes. The change detection was easy. How you decide to work with now that you've got the things that changed, what do you want to do with them? That's the part that gets a little bit more interesting. And so anyway, that's what we hope you'll find. And that actually brings me to the questions and answers. We do have a chunk of folks sitting there ready to answer your questions. And once I stop talking and hand it off, I'll join them as well. So do chime in with questions you have. And at the end, we'll sum up some of the interesting ones and we'll make sure to get back to you for sure. So don't be afraid to reach out and ask us questions as we proceed today. Yeah, so how do you even get started? You don't know what's changed with your data. What should you do? And I thought the best thing to do would be just to open up with a so-called flash demo. We'll get into it and do something really quick to see how we can identify changes to data. And today, at least for some of the demos, we're working with data from our friends at the City of Vancouver, who've had a long-standing open data portal that's been a wealth of information for citizens of Vancouver, but also if you've taken training from Safe Software, and our training is free, you have seen some of this data yourselves. So special thanks out to the City of Vancouver. They've got this wonderful open data portal. And today we're working with business licenses. I have done demos years ago with the dead animal locations spreadsheet, which is a fascinating spreadsheet, but Stephanie wouldn't let me this time. So we're going to do stuffy business licenses as our demo. And so we're going to begin where roughly half of, or the second most popular format in all of the formats we work with at SAFE. We're going to begin there in good old fashioned Excel. What we can get is a spreadsheet of the business licenses of, and actually we filtered it down to just be the ones in 2020. And you can see the license number and then, you know, lots of different stuff in here, when it was issued, the status, gone out of business. We're a little bit worried about that in this in these days of the pandemic, but you can kind of get a sense of what's going on economically in Vancouver if you watch this spreadsheet. And so we got one here from the 4th of September and one from yesterday. And, you know, just flipping between them, it's a little bit hard for me to tell what's changed. And so doing it manually wouldn't be too fun. I forget, I think there's about 4,000 records in here. So I'm going to start by using FME, that's the product we make. And I'm going to go ahead and add some data in here. So let me go to just pull down, I'll put in the, dragging in the one from the 4th. And this gives us what we call a reader, and I can see all the attributes here. And I'm going to drag in the one from yesterday. And there we go, there's yesterday. And now I want to compare these. Now I can turn on what we call feature caching, which allows me to see the data at each stage of our translation. So I can hit run here, and that's going to go ahead and run. These caches are now filled, and I can flip between these. So here's the one that's the 4th, and down at the bottom of the screen, you see the data there. And here's the one that's the 15th. And again, we can see the data there. And so now I want to do something to them. And to do that, we need to add a transformer. I could hit this button to start the search for one, or I can just type. I'm just going to begin typing on the canvas, as we call it. I'm going to say change detector. Oh, there's a nice change detector there. Detects changes between two sets of input features. That sounds like what we want to do. I put it down, and I'm going to say that my originals come from the 4th, and the revised ones come from the 15th. And now I got to go in here and say, all right, do I have a key? I don't know if I do or not. What do I want to match? And I'm going to say, I'm going to match attributes, and I'm just going to select them all. I want to know if anything changes at all, and I'm going to say okay to that. And now I'm just going to go ahead and run this thing. And just like that, I can see that 4,200 did not change. 13 are deleted. So let's just take a peek at the deleted ones. Christian's tutoring company looks like it's no longer there. And well, the Irish pub seems like it's no longer there. So let's take a look at the inserted ones. So these are gone, and these ones are apparently inserted. Well, there's Christian again with his tutoring, probably looking at international students. My wife actually lost her job teaching international students, so I'm not surprised that that Christian's is gone. And yeah, you know, the pub I think is out of business as well. Yeah, gone out of business. There's a few of these. So that's what's happened. But actually, there's also a lot of businesses that are, oh yeah, the Irish pub is inactive, but there's other ones issued. So businesses come and they go. If I wanted to do a little better, we do have a key here called the license, and I can go out here and say, let's compare or match things based on their license number, and that actually will tell me, if I run this again, maybe some things that are updated. So yeah, I didn't actually delete anything. There were 33 inserted, which means there's 33 new businesses in Vancouver, which is probably a good thing, and 15 that were updated, and these are the ones that are kind of going out of business and we're sad about. And so now if I had this, I could go ahead and add a writer here. Let's say write this to Excel and save out the changes if I wanted to, or report them. But that's what the rest of the demos today are going to be about, and I won't do any more than that. Whoops. Yeah, so that's the site for the business licenses, and I want to just advance to just, again, set the table. What are we talking about when we're talking about changing data? It can be about values of attributes, and that's what we were just comparing. When was stuff issued or what is the status. If anything changes there, we can catch all that. We can also do very complete geometric comparisons. So we haven't really introduced FME, but it's a data integration platform that started its life long ago working with spatial data and moving maps between different formats. And so we have a very deep and rich ability to deal with spatial information, but often that overshadows its quieter sibling of the attributes, who actually are very, very powerfully manipulated, and much can be done with them too. So it's really a 1-2 punch of geometry or attributes. If you don't have geometry, you don't need to care. My first example was not geometric at all, although some of the interesting things that Trent is going to show later especially are going to involve some scary geometry for sure. So up at a high level, there's a bunch of different techniques out in the industry that are used for capturing changing data to know what's changed. And the first one is like good old-fashioned Unix diff, which is just a old-fashioned compare. And that's what we were doing in my opening example, and that's what we're going to be doing today throughout our demos, comparing things for the purpose of extracting what's changed. And that's reasonable to do up to data volumes of even small millions, but and certainly for small thousands, it's a piece of cake. But for things larger than that, you probably need to get more sophisticated and graduate into the options 2 through 4. So we're not going to talk really about options 2 through 4 today, and I'll just hint that maybe if you're interested, we'll come back and talk about those in a future episode. But one of the techniques is if there's a date modified field, you can obviously just do queries based on that in your database and then report based on that. You can also jerry-rig your database so that anytime there's changes, a trigger in the database fires and writes the changes to some sort of a change table, and then you can just report on that. And you can also use some kind of logs in your database that might be able to be skimmed to understand what's changed too. And for those of you in the GIS world, if you're in the Esri universe, there's versioning that you can use the versions to tell what's changed. The database there, the Esri products will tell you what's changed between versions. Oracle Workspace Manager is another one, or Small World people have that sort of thing too. So sometimes different systems have specific things built that can tell us what's changed. And in all cases, there are ways of working with that, and we may come back to show you some of those in the future if you're interested. So why do we care? Well, it is often important to know what's changed. Knowing what's there now is great, but knowing how it's different than yesterday is a big deal. And so there's all kinds of action that might be taken based on changes for quality reasons, for reporting reasons, for efficiency reasons. And so we really find our customers often getting lots of value out of detecting and taking action based on changing data. After all, the mission statement of Safe Software is to help all of you maximize the value of your data, and that includes the changing nature of your data. And that's what gets us out of bed, even early in the morning like this, to do a webinar so we can help you with that. Again, at a very high level, we make 3 products at overall FME platform. We have the desktop that I showed a piece of already, that where you build the flow of the data. And actually, if you're just doing one-off or ad hoc things, that's where you are happily existing. But you can take those workflows and push them up to FME server, where they can run while you're sleeping, or when changes actually happen in the environment, when there's various initiatives and or initiators that take place. And lastly, you can take that server and you can host it in the cloud. And we have something we call FME Cloud, where you pay by the hour, and you can have those data flows there. And there's a mobile angle on this too, where you can access FME server services on mobile and do cool things like even see augmented reality. And there's a webinar coming up about all the ways we can get data from wherever out and into the world you live in. One last thing before I hand it off, just about the history. We started back in the early 90s working with the BC TRIM program, as it was called, and helping forest companies exchange information with the BC Gov. But this TRIM program had 7,000-ish map sheets mapping the entire province. At the time, in the late 80s, early 90s, that was the best mapped, largest chunk of real estate in the world. But the government realized that they needed to keep track of changes there too. And so there was a program called Trim 2 that was about revising all of those 7,000 map sheets to reflect new reality. And they wanted to track the changes. And so the Trim 2 program let you get the original Trim 1 file and then a set of things that were added and deleted. And FME ended up being used as the key piece of that. And so the technology that we're showing today was born to solve that problem way back in '98. So it's been tried and true for a very, very long time. Yes, everything that you're about to see is being recorded, and so you'll be able to watch again. I know a lot of people like to watch webinars or recordings at 1.5 or 2 times speed. Some of these demos you may want to watch at half speed, especially when the Trendster gets going, because there's a lot going on, and you'll and if you really want to dig into it, you are going to be able to. If you just want to cruise along at a high level and kind of generally know, that's great, and then you can remember that in case you come into situations like that in the future. But if you want to dig in, all of the workspaces that we did are going to be available for download. And actually, as soon as I hand off my presentation over to Nampreet, I'm going to zip them up and send them to Stephanie, my little example here, so you can even start with that. So anyway, we'll be sending you this. And so with that, I'm going to hand it off to Nampreet. He's ready to take the spirit of the demo that I did. I think, Nampreet, you've done a little bit more with it. You got a database involved. So why don't you take it away and set the table and tell us how you've changed our opening demo and what you got going.
Sounds good. Thanks, Dale. Yeah, so Dale showed us how easy it was to identify changes between 2 Excel tables with the ChangeDetector. We'll be diving a little deeper into the ChangeDetector to understand what actually is going on. Just want to check, can you see my workbench all right?
We can. Yeah,
Yes,
it looks
wonderful. So we're in FME workbench. We're using the same business license data that Dale was using from the city of Vancouver. However, as Dale mentioned, I've got a snapshot from about 2 weeks ago in a database table in SQL Server. So this is will act as our original outdated data set. Now our goal is to update this with the most current version available. To do this, I've pointed a CSV reader directly to the City of Vancouver Open Data Portal to capture their daily updated business license data. I'll quickly run this. And we'll read in the data set so we can basically see what we're working with before we get into identifying changes. I'm connecting live online to the Open Data Portal, so I'm thinking with the webinar it might be a little slower than usual, but it looks like it's coming. There we go. So you can see we have about 4,100, close to 4,200 records already in our database table, and 4,258 records coming in from the city of Vancouver right now. So before we get into change detection, what we want to do is look at the schema, inspect the schema, and see what we're working with. So oftentimes you'll be comparing 2 data sets, but the schemas will be different. Attribute names are used by the ChangeDetector to compare the data sets, and we have to also keep in mind that the ChangeDetector is case sensitive. So what we want to be on the lookout for is stuff like the case of the attribute names, whether they're lowercase, uppercase, using camel case, and you also want to see if there are any attributes that might be named a little differently. So right here, I can see that all we have here, the cases are basically the same. What we have different here is there are a few attributes that are not represented in our database table here, just like the folder year. So what I like doing is before going into comparing the data and identifying changes, is to get the schemas into the same format, or ensure the schemas are matching. So the way I do this is using the attribute manager. I'm using the attribute manager here to help get the revised data from the city of Vancouver to match the schema of our database table by removing any unwanted attributes. So you can see here, I've used the attribute manager here to remove any attributes that I don't need in my workflow. If I inspect this data, we'll also notice that the date format is a little different. So in the city of Vancouver, the year, month, and day are separated by hyphens, whereas the dates in our database table are not separated. So we want to ensure that the date formats are matching as well. So I'm also using the attribute manager to handle that here by setting the format of the issued date and expiry date. So coming to the star of the show here, the change detector. Let's add that to the canvas. And so the first thing we want to do is connect the original and revised data sets to the change detector input port. So we have our revised data set here from the city of Vancouver, and our database table containing our outdated data set table here. I can also just move this around. I know Mark Stokes, who's on Q&A, likes this, doesn't like crossed connectors there. So there you go, Mark, that's for you. I'll go into the change detector. And the first thing we want to do here is to tell the change detector how to compare the original and revised tables by choosing the key attribute. This is, if you're lucky enough to have a primary key, this is usually the primary key. Otherwise, you can also select more than one attribute here. So we want to, again, select one or more attributes that can be used to identify each unique feature or record. So right here, the attribute we want to use, our primary key, is the license RSN. And now we want to go down to the check attributes section here and tell the change detector which attributes we want to detect changes on. So again, the change detector is detecting changes on attribute values, and what we're doing is letting the change detector know which attributes or which fields, which columns you want to compare between the two tables. So what I'll do here is just select all, and I just like excluding the key that we used up here. The other parameters that we have available here are under attribute comparison. So this parameter here, differentiate empty, missing, and null attributes, can be used to detect changes, to identify changes between values that are set as null or missing, or which are empty, to differentiate those. I don't know, you may want to downstream make those consistent and when you write them out. But for our case here, we won't differentiate between those as well. We have another parameter here, which allows you to check for the data type or encoding differences between the attributes you're comparing. So that's a really powerful option if you're really looking to find differences between some of the schema components of the two tables. So we'll select no here. We're not interested in that for our demonstration. The last thing last thing we want to do here is a really cool option that we have is to generate a change list. So the change detector has an optional parameter which allows you to create a list detailing the changes that were detected. So all we need to do is name that list. I'll call that underscore changes, and I'll click OK. So let's run this workspace and see what we got. So yeah, you can see the change detector went through the features coming in through the two tables, and what it did was categorize the differences as updates, inserts, and deletes, and also identified those features that were unchanged. And then it spits them out into the corresponding output ports. So let's take a quick look at what it's outputting. So from the updated port, we can see all the records that were identified as updates. If we delve a little deeper here, looking at the feature information window, we can see we have that really cool attribute, attribute that we created, the list attribute that detects exactly what changes the change detector identified. So here, for example, we see the status of this record change from issued in our database table to inactive in our revised table from the city of Vancouver. If we go down here, got some more status changes. Yeah, so you can see how powerful this information can be. Trent will show you a little later how to capture this data into a report as well. The other thing that the change detector does is it takes care of setting an attribute called FME DB operation. So this attribute is a vital component of the change detector in FME and change detection in general in FME, and can be used downstream to set the feature handling action when it's time to write to your destination. So in here, you can see we're inspecting the updated output, and the FME DB operation has been set to update for those that were detected as inserts. The FME DB operation was set to inserts, and the same would go for any deleted records. So this again, it's very powerful, and it's really the real beauty of the change detector to automatically set this attribute, which we can use later in the workflow. So what we'll do now is move on to actually update our database table. So what we'll do is add a writer pointing to our SQL Server table here. Oops. This got a little squished for me. Oops. And what we want to do, sorry about that. Because it's an existing table, we want to import from an existing data set. And what this does is basically brings in the schema of that existing table. So we'll go click OK. And it'll get me to choose the table that we want to reference. And that's our business license table. Click OK. And here we've got our writer feature type added to the canvas. So now what we can do is connect all the streams coming out of the change detector. You really don't need to connect the unchanged data sets. So typically I would connect the updated, inserted, and deleted streams to our original table that we have that we want to update. So if we go into the writer feature type, you can see we have the feature operation parameter. So this is what tells FME how to handle the features that are coming into the writer. So by default, it's set to insert, but what we want to do is leverage the FME DB operation attribute that the change detector has set for us. And as if you recall, this will be set to either insert, update, or delete, depending on what the change detector detected. Table handling, we want to use our existing table, and what we want to also identify for any inserted or deleted records is our key once again. So this would be our license RSN as our match column. Let's do that, and what we can do here is run the workflow up until the end here. And what we're hoping is that we get our output, if we inspect that, should be the same number of records as our City of Vancouver data set. So we have 4,258 records, and we've written out, or what we have in our destination now is 4,258 records. Going back to our presentation. Actually, one thing to do, just for good measure, for a little fun, I'll rerun the entire workspace, and what we should, this is a little risky working with live data, but what we should get are no changes now that we've updated our original data set. So these two data sets should be exactly the same, and what I'm expecting is all features to come in as unchanged. I'm just crossing my fingers here.
You're gutsy, man.
Ooh, possibly one changed between when we ran it or earlier. I don't know what this record is, but again, the tools here allow you to inspect what was changed or not. So here we can easily see that the business trade name was changed here. So we got close, and I have a feeling it might either have to do with the selected attributes or the City of Vancouver pushed an update.
Actually,
well.
I did notice that one last night. That record is actually in there twice, so that it's not
really? Okay.
Yeah, that data, it's not a primary key, and that's because the Aquilinis, they're the guys that own the Canucks, and they must need to get into some other business, I think, because the Canucks are out of the playoffs.
That would explain it. Thanks for that, Dale. Yeah, just to recap what we saw here. So we had an original and revised data sets, and we used the change detector to identify and detect the changes between these two tables. And again, the wonderful thing about the change detector is it separates them out into separate outputs, updated, insert, deleted, or unchanged. And these are used to set the FME DB operation attribute for any downstream processing. We also have wonderful documentation on the change detector. Do check it out if you're diving into this at all. Some tips and tricks that I mentioned. Check your schemas. I personally like ensuring that the schemas are matching prior to going into the change detector. Again, I mentioned checking cases, ensuring that the attributes that you want to compare match, as well as date formats as well, sometimes are a gotcha there. So here's some transformers that might help with managing that. The other neat feature that I love about the change detector is this generate change lists, which helps you identify what actually changed. And as I mentioned, Trent will demonstrate how to use that downstream. We also have go full screen here. The FME DB operation. So this is what drives change detection FME. And one little tidbit about it, if it is set to blank or if there's no value for the FME DB operation attribute, it defaults to insert.
Preet, I should just quickly interject. Several folks pointed out that they wondered if there's automated ways for us to check if the schema has changed. And we never thought about it in prepping this webinar. This webinar was really imagined about changing the content of the data. But actually, we did a webinar a bit earlier this year called Schema Drift, where we showed techniques using FME that compare actual structures of tables. So it's kind of at the meta level, and we can read schemas and compare them. And so I might ask Stephanie to chat out the link to the Schema Drift webinar. If that's of interest to you, we go through a wide range of demos around that. So you can automate the checking of the schemas as well. So I'll just interject that, and I'll hand it back to you.
Thanks, and I'll hand it over to Trent, who will talk about reporting changes.
Yes, thank you. Just going to share my screen. Can everybody see my workspace?
We can.
Okay, perfect. So we're going to, for this demo, we're going to take a look at reporting changes. So Nampreet kind of highlighted a few times there about that change list that the change detector can create. Now, what we're going to do from that is we're going to create an actual report. Sorry about that. We're going to create an actual report that allows users to see what exactly has changed within their data, and then use those to drive business decisions. So to start, the data that we're going to take a look at is looking at the Victoria International Airport data that the Victoria Airport has graciously allowed us to demo. So here's just their original data set that they've provided to us in a geodatabase. And for the purposes of this demo, I've gone in and made some changes to that data that we're going to run against. So here's the workflow. Try to minimize this. Got my go-to thing right in the middle. There we go. So we're bringing in both data sets here. We're going to do a little bit of georeferencing just to make sure that our data is actually in the correct spot geographically. And then we're going to perform our change detection. One thing that Dale kind of touched on earlier was that while the workflows might look a little complex, the crucial piece is this part right here. Now, in each of the demos I will showcase, the little purple bookmark will be the actual change detector in terms of where actually the change is being detected between your two input data sets. Now, if we pop this open, what we're taking a look at here is you can see that I'm using a multiple update key. So what this means is because I don't have a unique key or a primary key on each of the features that I'm looking at, I'm able to make a unique ID by using multiple attributes. So in this case, I'm using an auto incrementing ID, which is the object ID, and then the actual feature, the feature name that is coming in from the source data sets. For the purposes of this demo, I'm only going to look at two attributes that I know have changed or that I have manipulated in some way. Then we also are going to look at the we're going to look at the geometry of the features because some features have been changed for the purposes of this demo. We won't go through all of these parameters at this moment, but for the with this being 3D and data architectural data with floor plans, we are going to take a look at the full geometry, and what that means I will touch on later. And then of course, we're going to generate that list. Now, when I run this through, you'll see that I get 6 updates and 2 deletes, and then no changes and no inserts. Now for this, I'm going to generate an HTML report that's going to outline to the user or the reader what has exactly changed and whether or not the changes were updates or deletes, as well as kind of generate a little bit of a map that's going to highlight the changes in the original data set. So we're doing kind of a little bit of just HTML table generation and map creation, and then we're going to write out to an HTML report. Now, when you run this through, this is kind of the report that gets generated. We've got a list of updated features here. Because I don't have a lot of actual important attribution on the features, that I just wrote out kind of a basics of the feature ID or the object ID that was affected, and then the type of change that was witnessed. So in this case, it's a geometry change. And then lastly, we have the deleted features. Now, kind of perhaps, the kind of the most important or kind of the key piece or the key informative piece is that I was able to generate a map, and I've got the red you see is the original data set, and then the blue pieces are overlaid on top of that, and this is showcasing what exactly has changed. Now, you could take this a step further and have the attribution be available in this map through toggling the individual features that have changed. But for this purpose, I just left them as updated. But you could have the full attribution being outlined here. Now, if I wanted to take that one step further, I could have this be as the key piece of a foundational for downstream or downstream processes. So in this case, I could have a directory watch where it's monitoring this directory. I'm going to have users push their floor plan edits to this directory. I will then monitor those, and then if a change is change is found, it would drive up downstream process. So in this case, it would could then drive a full completed IMDF model that could then be imported by users into their Apple Maps, for example. And then I can email and notify users or the boss man, if you will, of that change being outlined or being achieved. So kind of, just kind of to take a step back, and what exactly did we just do in that demo? So we read in two different data sets comparing Victoria Airport floor plans. We then performed some change detection, both from the attributes and the geometric or spatial side using a double key. Now, I used a double key there, but you could use as many keys as you need to in order to get to differentiate those features. Ideally, one key would work, but not all data is the same. We then generated a list of what was updated along with any new or missing features. And from that list, we were able to create a report that notifies us of which features were updated versus inserted or deleted. And then we created a map for that change detection report. And then, as I touched on, the next steps could be that, this is going to drive downstream processes of generating a brand new IMDF model if changes were found. Obviously, you do not want to go through that entire process if no changes are found. Now, kind of, some tips and tricks regarding that demo. So if you're working with a vast quantity of data, if you will, especially, or a large number of attributes, you can use a CRC calculator transformer before the change detector. Now, what this does is this will generate a CRC code based on either the attributes, the geometry, or both. Now, what this allows you to do is essentially it allows you to throw out those attributes in terms of the change detector does not have to compare against each individual attribute. It will generate against the code. Now, one important caveat with the CRC calculator is that it requires that the attribute order be the same. So if you are sure, if you're 100% confident that the attribute order has not changed between your original and your revised data set, then you can use the CRC calculator to gain a pretty significant performance boost. Now we're going to jump into another demo. So this is the idea of identifying and applying geometric changes. Now for this one, we've got parcel data from the City of Langley's open data portal. So thank you for the City of Langley, or I think it's the Township of Langley, actually. So here we've got their data that I've just loaded directly into ArcGIS Online. So I can just click around and it's just parcel data with some lines, breaking up the parcels. Now I've also, this one, I might not have that shown open right now, but what I've also done is I've got a new CAD file with some changes. So if I pop that open, here's my new revised. Now I could, go back and forth between the two images and try to figure out, what exactly has changed, have any parcels been edited, have new parcels been added, but nobody has time for that. That just takes too long. So here I'm going to just do some change detection and then push those new changes back into my system of record or, my ArcGIS Online. So mentioning again, here's the key piece of this workspace or this workflow is this is the change detector. Here's where the bread and butter happens, if you will. Now, if I pop open the change detector, we'll see it looks slightly different in terms of how I have it set up this time. So we'll notice that I have no update key being set. Now, what this means is that I will only get inserts and deletes out of the change detector. No updates will actually be produced, mainly because it doesn't know exactly which features are supposed to correspond with one another between my original and revised data sets. And then from there, I'm not really, with it being partial data, I don't have much in the way of attribution on top of it. So I'm not worrying about, looking for attribution changes. I'm merely going to worry about the geometry. And because I know the geometry is 2D only, or while it could be 3D, there's no actual elevation data being set on it or values being set. I'm just going to worry about the geometry being the matching of 2D geometries only. So we'll only look at that X and that Y value for each of the corresponding features entering the change detector. And then kind of one thing I do want to point on here is this lenient geometry matching. Now, what this does is this means that FME or the change detector will not worry about the order of the points or the vertices that make up your lines and your polygons. Now, the reason being is that your two different your original and revised data set might have the order of geometries being in a different order. If you care about the order of vertices being written for a polygon or a line feature, then you would want to toggle this to no. But for the purposes of this demo, I'm going to keep that as yes. And then lastly, the kind of, one key part I want to highlight here is the vector tolerance. So with the FME, we'll go through, we'll try not to alter any of the geometry that enters through the readers. However, different formats can handle varying degrees of precision, or decimal places, if you will. So what this vector tolerance does is it allows us to set a kind of a rubber band, if you will, in terms of where will we treat as matching, what features, what's the length of difference we will allow for before we actually flag a difference being found. So for this case, it would be 2. So if I have anything that's greater than 2, then a match will be flagged. Anything less than 2, and a match won't be flagged. So I could set this to 6 decimal places to really, I want to let 6 decimal places be allowed before any type of change is found. But this is really a user-specific parameter that allows you to specify how much leeway do you want to give FME before any type of change is found. And then for this one, we're not creating a list at all, because we don't worry about what's being updated, because we are merely working with the inserts and deletes, because we're not using an update key. And then from there, I've just pushed the data back into ArcGIS Align the changes. So in this case, any of the inserts. So kind of, to cover again, so what did we look at in that demo? So we read in parcel data from our system of record, being ArcGIS Online. We then read in the new subdivision parcels that have been submitted, along with any changes to the existing parcels. And then we reprojected those new plans just to match that of the ArcGIS Online features. And then we detected changes between the original and the new design plans. And then using a vector tolerance, where we're able to compare the geometries between the two data sets to figure out if anything has been inserted or deleted. And then we wrote those new features back to ArcGIS Online. So kind of, I want to take a step back again and just kind of graphically display what I was trying to explain with the vector tolerance. So setting that vector tolerance, when and why. Now, we have a very good blog post here that kind of talks about the precision tolerance and how FME handles that. That is an excellent read. Highly recommend that if you're not super familiar with precision in FME. But showing this, using this image as an example, if I had a vector tolerance set at 0, so I'm not using a vector tolerance at all, any type of change will be found down to like the 8th decimal place. Now, if I set a vector tolerance of 1, for example, this change would not be found. Or rather, sorry, if I set a vector tolerance of 3, this change highlighted in this image would not be found, even though there is a 2-meter difference. Now, the units that are used by the vector tolerance are always the units of the feature's coordinate system. So if that's meters for the coordinate system, etc. Now, kind of our last demo that I want to go through is this idea of a change detection scenario. Here we go. So what we're looking at here is this is just road closure data generated from the City of Toronto's open data portal. Now, I loaded this data in a couple of weeks ago, so I would kind of, be sure that we would get some changes and some updates. Now, this is just my original. I've just loaded into a geo package. But the new data that we're going to generate, that I generated earlier this morning, is being taken directly from the City of Toronto's open data portal. Now, I am doing a little bit more of a complex method here, but I kind of wanted to show this because I'm getting this directly from the API. So I'm just using an HTTP caller that goes directly to that API, and then it will I break out the JSON response that is being returned to create my features. So in the change detector here, again, this is the key part of the workflow. If I pop that open, so I have an update key, this closure ID that I'm using. I'm also checking the attributes here. The ones that I'm not worrying about are my ID, which I could leave that in there, and the latitude and longitude. The reason being is that I've actually broken this out into an actual geometric feature, so I don't have to worry about the attribution. Although if I wanted to, for a second level of comparison, I could check the actual geometry as well as the attribution that is referring to that geometry. And then I'm also, again, generating that list because I want to know what exactly has changed. So we'll see when it goes through the change detector, I get 42 new features. I get 362 unchanged. I get 322 deleted features, and then I get a single updated feature. Now, kind of one thing I do want to touch on, because Nampreet was using a special ID in his example of updating, of writing those updates or deletes back to his original database table. In this case, because GeoPackage gives you an ID that you can make use of if you would like, a feature ID that can be used for the updates and deletes, I'm going to use that. Now, currently with the change detector, it does not allow for attribute accumulation, basically merging the original with the revised. So I'm using a feature merger. And that all that is doing is it's allowing me to get that original feature ID that came in from my original, and I'm going to apply that to any of the updated or deleted features. That way I can ensure that I'm updating the correct feature or deleting the correct feature in my destination table. And that's there. I also wanted to publish this to, I don't want to have to go through and run this change detection workspace every time. Maybe I want to throw it up on FME server, and I can just set it to a schedule, and it's going to, check for updates, once a day. It could be once a week, once a month. It could be daily, once an hour, depending on the rate of change that you're expecting. And then I can then have it email based on if it's going to succeed or if it's going to fail. So I had this one run this morning, just letting me know that, hey, the road closures have been updated. So that can then be used to drive downstream processes or business decisions. So now it's time for tea time, as I like to call it. It is trends, tips, and tricks. So one, we've got the update key versus no update key. So the update key is only required to get features flagged as an update. If you are not expecting updates or do not care about updates, you do not need to set an update key. You will merely get inserts and deletes. Now the attribute comparisons. So while the change detector can handle comparing all attributes, limiting the number of attributes to only those that you would expect a change to have occurred will increase the performance of your workflow. Now, by default, we don't treat missing, empty, or null attributes as different. However, if you want that higher level of complexity in terms of treating those missing, null, or empty attributes as different, then you can set those. You can set that flag in the change detector. And the same goes for the attribute type or encoding. Is by default, we don't care about those, but you could toggle those on. That way, the change detector will look at the type, encoding, and the value of each incoming feature. And then we have the geometry comparison. So we looked at, in these examples, we looked at the full geometry matching and the 2D methods. So the full geometry matching, This will compare the sidedness, the traits, and the properties and values. So that's, kind of where you're working with, CAD data or something that's more complex in terms of a geometry. If you're dealing with just, points and polygons with 2D and 3D data, you don't have to worry about doing a full geometry match, because the 2D and 3D will compare just the property and the value, so that X, Y, Z coordinate. And then again, that lenient geometry matching is probably the most important parameter, I would argue, due to the way that if you do not care about the order in which your points were written that make up that line or that area or polygon, you would want that set to yes. Otherwise, set that lenient geometry to no, and that way you can confirm that the order was not changed at all. And then that vector tolerance, which I cannot, stress enough in terms of, especially when you're dealing with different systems of data. Now I'll pass this back to Nampreet to take us home.
Yeah, so hopefully with the scenarios we demonstrated today, you can see that change detection in FME can be easy. FME cuts out any manual effort, and there's also no coding required. Change detection FME gives you the power to detect, report, and apply changes to your tabular and spatial data sets. Incorporating change detection in your data integration workflow can help increase productivity by helping you operate more efficiently, saving you time from doing tedious tasks.
Nice. I will chat out some of these resources then. Trent, are you good just to do the slides to the end, or did you want me to pass control to anyone?
Nope.
Oh,
I can take the rest of the way. So
I'm
yeah,
sorry
we have
about that. I think I was on mute there. Sorry about that. Do you want me to talk to the previous slide again?
No, we got that
No.
part.
Oh, you did. I don't know how I went on mute there.
Yeah, so we have
that.
some resources here. We'll send these out after the webinar, and then you will be able to access these from the slides. So I know all the questions that are coming in. It's Trent, how do we start? How do we get started with the, managing changing data? So why don't you head on over to safe.com and go to the downloads page. You can download the latest edition of FME 2020.1. You'll be able to download the workspaces from this webinar within 24 hours or so. And then you'll be able to, use those workspaces and apply them to your own data and start managing changes. Now, what would a webinar be without some type of licensing mention? So we do have subscription licenses. We also have individual and cloud deployments. So if you have any, specific questions related to licensing, please feel free to reach out to us. And then, as highlighted earlier, we are toying with this idea of doing a part 2 that would cover 2 through 4 of those change detection methods. So if you'd like to, like us to do a part 2, or if you're keen on only one of those aspects of change detection, let us know in the survey, and we'd be happily obliged. And then we have some upcoming webinars. So tomorrow we have SAFE's process of migrating the FME community to a new platform. That is super exciting and quite interesting work that the team here was able to accomplish. And then we have an upcoming one that I believe Mark might be actually delivering, which is 5 ways FME can improve your Excel data. So please, join us for those dates. And then, yeah, so if we'll kick it over to some questions now.
Wow,
Yeah,
you can tell that Stephanie,
sorry,
look at
go ahead, Dale.
Stephanie, what time is it?
It's 9. So yeah, I was just gonna thank everyone for attending today, and we will stick around for some additional Q&A if you have the time to hang around with us. If not, we really appreciate your time. We hope that was valuable. And if you have additional questions, you can reach us at safe.com. We have a live chat there. We also have the FME community at safe.com/community. So if we didn't get to your question, or if you go away and have more, that's where you can find us.
Excellent. So our Q&A folks, do you want to chime in? What themes did you see today, and anything else we should add for the folks at home?
I think the main theme that I saw there in the lots of great questions that we've had was just clarification around when you would use the update detection key attribute. And Dale, I'm wondering if you could just bring up your demo again and just show the difference between what happens when you use that key and when it doesn't, because I think there was a few questions around that.
All right, so here, with any luck, Mark, you're seeing my screen.
Yeah, and it's really about the idea of having a persistent key on the two data sets, which you do have, and not having a persistent key.
So again, if I wipe out that thing, now there's no way to know what's updated, right? So the updates come out as none because I've got no key set. So if we got no key, all we can know is if things seem to be added and seem to be missing. And I saw somebody asking about CAD file comparison. In CAD files, there ain't no key that in normal situations. So the best you can hope for is what's added or seems to be deleted. You can't tell what's changed. So in this case,
and so essentially, I think what's happening there is you have to compare each original feature with every revised feature to figure out which ones might match or not. Is that right?
Yeah, I mean, if people are interested in how this thing works underneath, what we actually do is we build a key out of, well, I shouldn't really use that term. We basically are clever and glue together all these attributes the values for all these attributes that are clicked here, and build basically an in-memory database of all the combinations of values. And then we check, is there a match between the original and the revised? And that's what we do. And all we can tell is if there's a match or not. And if there's not a match, then that means if it came from the original, it's been deleted. And if it came from the revised, then it must have been added. The geometry checking is done after we do the attribute checking. And so, yeah, that's the best we can do. But if we actually know that there's a key, now the world is a much nicer place. And we say, okay, if there's this license business, now we only need to we first kind of check on that key, what's going on, and then for the same value of that key, we can tell if the rest of the attributes don't match, then it has been updated. So the City of Vancouver data set is interesting because they never really delete stuff out of there. They only mark the licenses as inactive. So it's never, like in this data set, it would be nearly impossible when the key is working, if the data is correct, to ever have a deleted record because they don't delete them. They just keep them there forever, but say that they're inactive. Mark, it seemed like as well,
Thanks.
folks were quite interested in the geometric side of stuff too, and a lot of questions around tolerance.
Yeah, that's true. There were. So I think some of them are around questions around that freshet distance and the dog walking. So we've given out the link to that. And then the other one really is if you're using the trick with the CRC calculator to convert the geometry into an attribute, then you might need to round your coordinates.
Yes.
Because if they're coming from different sources, then there might be a bit of dithering on the coordinates. So you can use the coordinate rounder to make them more consistent between the original and revised, and that will work very well as well.
Yeah, this freshet distance business, Mark Ireland wrote a blog on it last January or January 2019, and this diagram is the best. So the blue is, let's say, the revised, and the red is the original, and the tolerance is basically the maximum length of the dog leash. If the blue is your dog that's going for a walk and the A is you, the F is the size of the leash that if you're that or less, then it's a match. Otherwise, it's not. And that's a very, very powerful improvement on the geometry matching for sure.
I think that's about all the ones I had.
Excellent.
Outside of the schema drift. And so actually that is confusing. We need to change that. So the schema drift webinar, I think we should put a link into the webinar slides so that goes up there, because when you search our webinar site for change, the schema drift thing doesn't actually come up. So, so we do need a link in the webinar slides that get posted to the website.
Yeah, yeah.
Nice. I think Dale's gone ahead and added that already.
Yeah. Yeah, I never thought like schema drift really is change detection, but at the meta level. So yeah.
Yeah, maybe we have to update the description so that it pops up for people. I'll make a note.
And I did actually also, Bruce Harold, thanks for chiming in, Bruce, pointed out that webhooks are like the modern version of database triggers. Database triggers are so 1980, Mark. The cool cats all would be using webhooks today. All right.
Nice. Yeah, there are a lot of questions coming in. I'm just keep scrolling through them all. Lots of really great questions and comments throughout the webinar. It's a lot of fun. So thank you everyone who chatted in a question and took the time to share a nice comment. It's just a lot of fun for us when it's interactive.
Yes.
Cool. Well, then if nobody is seeing anything else, you guys are all good. I think then we are probably good to close this down. What I'll do though is I'll leave it running for another couple minutes. We'll turn off our audio and stop the screen share, but I'll leave it up for about another 5 minutes. And then if anyone does have a last question, they can go ahead and type that in and we can get back to you. And like I said earlier, if you go away from this webinar and realize you do have questions, you can reach us on live chat. You can see on Dale's screen right now, there's a box there that says chat with an expert. You can go ahead and click on that and type in any questions. You can also go to our brand new FME community at safe.com/community, and that's a really great place to reach all our experts too. It's a super valuable resource for sure. Nice, good example, Dale. Love it. That's awesome. Cool. All right, well, I'm going to go ahead and take back screen control here, and then with that, I think we're probably good to say goodbye.
Goodbye, everybody. Thanks for tuning in.